IU Matters Concussion Research is a co-production of Indiana University Office of the Vice Provost for Research, Indiana University Media School, and WTIU.
Just ahead on IU Matters, the groundbreaking research underway right here at IU, which stands to affect anyone who has taken a hard hit to the head. Concussions, straight ahead on IU Matters. Hello, I'm Ann Ryder. Welcome to our very first program spotlighting important research now underway in Indiana aimed at improving the safety, health, and well-being of people everywhere. The focus of our first program likely touches someone you know, a friend, a family member, even a son or a daughter. It's the effect of concussion. Whether it's a grade school child just starting in sports or an NFL superstar, the consequences of concussion can be life-changing. What kind of research is underway to detect concussion and reduce the threat of brain injury? Well, we have three prominent researchers here today to talk about some of their groundbreaking findings. We'll talk with them in just a moment. First, though, a bit of background. Research is underway on multiple fronts to better detect concussion, and some of that important work is underway right here at Indiana University. Here's reporter Katie Billman with a look at one project aimed at diagnosing concussion immediately and what that means for parents and for athletes.
High school athletics can be a source of team spirit, student camaraderie, and on some occasions, serious injury. Bloomington mother Barbara Jager has always worried about letting her kids play high school football. She says she didn't want them playing because of the repeated concussions they got in middle school.
They didn't even know, that this happened, and they put him back out there because he was a good player. And you hear of this, the second injury, and where you get the swelling in the brain. And, that just scared me to death.
Nearly half of concussions happen in high school football, and a third of concussed players report getting more than one in the same year.
This fall is the first season that Jager's letting her son play football here at Bloomington South High School, and it's because of some new technology that keeps student athletes a little safer.
IU scientists Nicholas Port and Steve Hitzman have developed a tool that detects concussions just moments after they happen. The device tracks athletes' involuntary eye movements to first establish baseline numbers. After a high-intensity blow, the athlete immediately retakes the 5-minute test, and the team compares the sets of data.
Yet if we see an impairment there, that would be a very objective, computerized, involuntary measure of sensory motor performance. And that could then give a result to the clinicians.
His research partner says the tool aims at the gray area Jager's son was in, where it isn't clear if the athlete is concussed.
Within the mean, they go back in. Outside the mean, they don't. And it takes all that subjectivity out of the hands of the doctor and the certified athletic trainer, and that's what they want.
And according to Jager, parents want it too.
Now, let's get some more answers about detecting concussion. And joining us are three leading researchers in the field. First is Dr. Tom Mcallister. He's chairman of the psychiatry department at the IU School of Medicine. He spent the last few years guiding a multi-million-dollar project to reduce the impact of concussion. Also with us is the researcher featured in our opening report. We'll hear more from Nicholas Port on eye movement technology to detect the effects of a possible head injury. And researcher Casuada is also with us. He's testing a device designed to better detect the consequences of repeated head impact. It's actually a mouthpiece. But let's start with Dr. Tom Mcallister, who has been overseeing Indiana University's contribution to the largest ever research study on concussions. This is, 3 years, $30 million effort from the NCAA and the U.S. Department of Defense. Dr. Mcallister, thanks for joining us.
My pleasure. Thanks for having me.
Massive effort here. What kind of data are you collecting and what are you learning?
Well, I think it's a very ambitious project, and Nick can testify to that later on. But basically, there are two sets of data. One is clinical symptoms having to do with concussion-like symptoms, measures of balance, measures of cognition, and so forth. And we get those at baseline before the season starts. And then if someone is identified as having or suspected of having a concussion, those are repeated. The second category for a subset of the athletes is a much more detailed assessment using magnetic resonance imaging, fluid biomarkers, genetics, and head impact sensors in the helmets to get a much better sense of the neurobiology of concussion if we can.
But with this collaborative effort here, you are hoping to really break some ground in terms of how this data will be used, correct?
We hope so.
Yeah.
Basically, the effort was funded because it was realized that we really know very little about the natural history of acute concussion. How long does it take to get better? And most of the information we have comes from men and most from male football players. And so that leaves a very large gap in other sports and particularly in women athletes. And so this study is examining all sports, both men and women's sports. And so we're hoping to get a much deeper picture of the injury.
But concussion affects so many people in so many different areas of life. I'm just taking a poll here. You have had concussions. I've had concussions. I don't know about
I have.
You have too. Okay, we're all members of the club here. Yeah. All right. Well, let's also get a little bit of an overview here from Nicholas Port. We know a little bit about the work he does. He's an associate professor in neuroscience at the IU School of Optometry. You've worked extensively with high school students, college students with this eye movement tracker. Give us sort of the Cliff Notes version of what you're learning here.
So we've been doing this study with roughly 1,600 athletes at any given time for 3 years now at the full-size study. And we've been, we collect a baseline on everybody, and then we collect a post-injury, usually within 15 minutes. Occasionally it's an hour, up to 24 hours after the injury. And we do a battery of 5 tasks with 3 different eye movement systems. We measure balance simultaneously while we study the eye movements. And it's so far looking very promising as a tool to give you a very objective measure of brain health and sensory motor performance.
We have a little bit of video that I think we'll be showing later as well, but this is of you collecting the baseline. That baseline is essential, isn't it?
Well, we will find out in the end. I feel it's safest to do it. We know from the oculomotor literature that the test-retest variability in sensory motor performance, especially in eye movements, is very tight. So if your eye movements are very good on one given day, a month later they're still likely to be very good. And if your eye movements aren't so good, they're also very likely to be similar. So unlike cognition, which can vary a lot by motivation, sleep, attention, many different factors, sensory motor performance varies a little bit less. It's possible that this type of technology and research could be used without baselines. We simply don't know yet. So it was safest to do a baseline on everybody to maximize our chances of success.
So clearly we're moving from subjective testing to objective testing, and that makes all the difference in the world, doesn't it?
Yes. Obviously subjective testing has a lot of outside variables. Things like motivation, which I just mentioned, are certainly part of it. Also, especially in the sports setting, or probably also in the military setting, the effects of adrenaline and cortisol and the excitement of the game or the heat of the battle in the military setting will greatly mask any mild traumatic brain injury.
Third person with us is Keisuke Casuada, who is testing a sensor installed in the mouth, and it's designed to measure the impact that athletes endure. It can be used for a variety of sports. So tell us a little bit about this mouth. You actually brought one, didn't you?
I did bring one.
Yeah.
I did not invent this, but I work with the company. I think it's brilliant, from Seattle, the Athlete Intelligence. And this is the one installed with accelerometer to detect the linear motion of the head. And also it has a gyroscope to detect the rotational head accelerations. And what's good about this is we can detect the cumulative effect of each impact. How many impact can you sustain in the season which are safe? That's the aim of this study. And in order to detect the safety or safeness, we do blood biomarkers and eye movement sensor. And the study that I conducted before at Temple University in collaboration with Dr. Diane Langford. And we found that if you sustain more impact, you see some chemical that came from brain in the blood, which is not ideal. So
I'm reaching across because I'd love them to get a shot of this. I'm sorry if I'm touching the mouthpiece. Is
please.
that allowed?
Go ahead.
Okay. Because this is a rather expensive piece of equipment, is it not?
It is. It's about 200 to 250 per player.
And so which athletes will get this? Obviously the ones that endure the most impact. Let's see. And okay. So they've got the helmet on, the face mask, which protects this very important piece of machinery at the end, right?
That's where the sensor is installed and antenna as well.
Okay, that's what it looks like. Okay, so what athletes will get that, for instance?
So this one, currently we are installing in high school football players, but we could use this one in ice hockey team. But since there is a protrusion in the sensor, we have to use this one in helmet-based sports. So we cannot use this one currently for soccer or field hockey. But I think implication is immense, and now technology is evolving to evolve to reduce this protrusion, everything back to this circle. So that's where we're heading to. But that's a study.
That's what it's, and you three know each other. Do you collaborate on some of this research? How does that work?
Yes, we do. So IU Bloomington is one of the 30 sites for the study that you mentioned. It's called the CARE study. And Nick is the site principal investigator for Bloomington. So some of this research is happening right here on the campus, and they're making an enormous contribution.
Very exciting. I know we have some video that we took out on the football field. This was practice.
Yes.
And you go out to almost every game, don't you, Nick?
Yeah, I go to every game and during camp, which is where the footage is from. I was at every contact practice and training camp.
You know, I've heard different things about how men and women react to concussion. And I realize everybody's a little different, but you already mentioned, Tom, I believe, that women you're finding are more susceptible to concussions. Can you all tell me a little bit more about that?
Sure. As I started off earlier, we know relatively little about concussion in women. But from some epidemiological evidence, not in this particular study, but that seems to be confirmed by this study, for sports that both men and women play, such as basketball or soccer, the rate of concussion is significantly higher in women. And we don't know really why that is yet. There are lots of theories that have been proposed and so forth, but we don't really have the definitive answer to that yet.
Kay, you kind of monitor with the various head movements. What do you find relative to men and women in that?
So the research is somewhat consistent in the way that the neck strength does affect head movement. So which means the strength of the neck muscles, if you have a very strong and stiff neck muscles, it does reduce the movement of the head after the impact.
Like a linebacker or
linebackers
something.
Or offensive linemen compared to gymnasts that are top of the, or cheerleaders who do not really necessarily strengthen their muscle in the neck. So if they sustain same amount of head impact, we see that the head moves more in those who have less stiff or less resilient muscle in the neck.
In this research has already been influencing how a lot of strength and conditioning coaches approach their sports. So I believe at Indiana University, and I'm going to guess actually a lot of institutions at this point, have increased their neck strength conditioning for female athletes, both in sports where it might make a little more sense, like soccer, where they actually do use their head, but even in the other sports that are, say, field hockey, which is a concussion-prone sport, but not one where they actively use the head. I think the strength and conditioning coaches are increasing strength exercises in many women's sports.
Now, Nick, you're on the sidelines with this eye tracker, so that when they take a big hit, you go off and you measure because you have a baseline.
Right.
What is a concussion different in the first 5 minutes as opposed to, say, 20 minutes or an hour later? Does it have a cumulative effect? Because we've all seen athletes who say, "Ow, I'm fine, put me back in."
There's an enormous amount of variability. So some athletes are greatly impaired, and if anything, might actually slowly progress a little bit, get a little bit better as the afternoon and evening proceeds, and you're monitoring how they're doing, because we always do that with collegiate athletes, monitor them for several hours. For other athletes, it's probably the reverse. They feel just fine, and they may be resistant to us benching them, but then they will deteriorate. So there's an enormous amount of heterogeneity to it.
Either of you have something to add?
Yeah, I think one of the things that surprised us is that about a third of the athletes that we've studied who are diagnosed with a concussion did not report their symptoms right away. So we're used to seeing somebody take a big hit on the field or an obvious collision in some sport and drop into the ground, and people can say, oh, yeah, that's probably a concussion. But there's about a third of athletes for whom it's very difficult to actually pinpoint which impact may have caused the injury, and many of them do not report for a day or two after the event.
Well, and this has been such an issue in the NFL because if you have a shorter duration between concussions, between these big hits and the effects of the brain, what does that tend to do?
So the animal research have already shown if you receive the big impact, concussive blow to the head, you do see the surge of the ions and rush into the neuron cells, and it makes temporarily they're vulnerable to subsequent hits. But it's so difficult to validate that in human because it's impossible to get living cells, brain cells from human. But those studies are very consistent in the way that if you have a very short interval and time window, and your brain becomes very susceptible to, or before adequate interval to recover, your brain becomes very, very susceptible to next impact.
What kinds of things do we see? I mean, we've all heard about the Aaron Hernandez case, and but can we see over time, mood swings, susceptibility to dementia, those kinds of things? Are you measuring that, or is that for the future?
So, a very controversial topic, as you know, but a good one to be talking about. So in the study that we're all involved in, we do measure some psychological health instruments. So we measure symptoms such as depression or anxiety, sleep, fatigue, etc. That's part of a concussion checklist. And those symptoms are so common as to be considered part of the core component of an acute injury. Because the study follows athletes only out over 6 months, which is a lot longer than many studies have in the past, but nevertheless it's 6 months. It is not a study designed to diagnose or indicate chronic traumatic encephalopathy, or CTE, which is the condition that was publicized with Aaron Hernandez. We hope to be able to follow the athletes that we've been enrolling in the study for over time in order to address that question, but we'll have to see.
Mm-hmm. There are parents like Barbara Yeager, who we saw in the video piece before, who are starting to think, I'm not sure I want my younger sons to even play football. Comments about, that kind of thing.
I think it's a very personal decision, but it's really important for families and for society to weigh the benefits as well as the risks of any sport, whether it's a collision sport like American football or soccer or something that has less concussion prone. There's a lot of benefits to playing organized sports for many of our children, and we have a diabetes epidemic, we have a obesity epidemic in this country. Children, the #1 risk factor for high schoolers is car accidents and suicide for mental health issues. And we know from many studies for many decades that participating in organized sports greatly protects you against many of these things. So while it's a personal decision, and I think each family has to make that decision themselves, and each child then is very dependent on the context of them, I think it's very important to think about both the benefits as well as the risks of participating in youth sports.
I think I said her name wrong. The last name is actually Jaeger. I wanted to correct that. How significant is IU's role in this research? And I realize that's a broad question, but it looks to me that we're doing quite a bit in this area. Tom?
Yeah, absolutely. I think and it's two components. There's the large study that we've been talking about with the 30 sites and the Department of Defense and the NCAA, and IU Bloomington playing a huge role as one of the sites. And the School of Medicine is serving as the administrative and coordinating center for that entire operation. So that's a fun role, and we're serving as the biostatistics and the data biorepository as well. And then there are individual efforts like Nick and Kai are talking about, which really are very exciting and in their own right, independent of the other study in which some of the efforts are embedded. So I think it's we're sort of at the epicenter.
And this is not all, oh, I'm sorry, go ahead.
I was just going to say that we have the pleasure here, the three of us, of being on this television program, but there's more concussion research, especially happening up in Indianapolis outside of us three. So Brandon McDonald's been doing a lot of neuroimaging in youth athletes. Dr. Sakin's involved in several projects. And then I believe they've been recruiting some new animal model people that Tom may be able to mention. So I think the concussion research is expanding at Indiana University.
And you travel to California for your part of it, correct?
I do. So I collaborate with Dr. Steve Zahner. He's a sports medicine physician, and Carmen Charleston. And we do study across the Indiana and try to collaborate multi-center study. And those collaborative effort is necessarily, just like Nick and Tom is mentioning, one person or one investigator cannot solve this problem. But I think IU does play a big role, and an important critical role in order to advance our knowledge. And I just fit the very small piece into it.
Give us, if you can, a kind of a laundry list of what you can say for sure, or what you believe you've learned about concussion and tracking all of that.
Well, for speaking for the eye movement study that's been run in my laboratory, I think the data is very promising that we can use a combination of eye movements and balance to diagnose a concussion using purely objective and instrumented tools. And then I think for the NCAA DoD study that Dr. Mcallister is the head PI on, the list is almost too long to present. I think there's 22 publications already in the pipeline, and they probably get 10 a month of proposals. I've written several proposals to them, so it's going to take decades to finish off that data set.
But for instance, we know that if you get 2 concussions in a short period of time, that is usually worse. Are there any other things that we know we can deduce at this point that would be helpful?
Well, I think Kai may have some interesting comments on this. But I think one of the things that we've learned in looking at the biomechanics of concussion and harking back to this idea that not all athletes report right away. Some of that may be that they don't want to report, or some of it may be they're not aware of all the symptoms of concussion. But some of it is there's an enormous individual differences in terms of each person's brain susceptibility, and we have some folks diagnosed with concussion after a really big hit, as you might expect, recorded by sensors, and then we have others who are diagnosed with a concussion after relatively modest hits, and not that I would want that kind of hit, but but nevertheless, that has raised the question that you're alluding to, I think, of is it more the context of when you get hit? So if you have been subjected to lots of hits in practice or a game immediately before that, are you more susceptible? And the evidence is beginning to suggest that, and that's what's prompted the NCAA and other bodies to look at how much contact there should be during the week in football, for example, and some of the other collision sports.
Is there evidence that the younger the athlete, the greater the potential damage, in the sense that the brain is, I don't know, that they're younger? Anything like that?
Not
really.
No conclusive. But I
Okay.
think it's the sleep plays a big critical role in the brain's resiliency to maybe many impacts or big impacts. Because I am running the study right now to see the effect of sleep deprivation on the subsequent hits. And when you combine those, and the data shows those perturbation or change in the brain system is exponential. So it's striking to me those high school students and college students don't sleep enough. It's striking that if you don't sleep enough and the brain is operating under a sleep-deprived state, and the brain may be more vulnerable to modest hit and then have symptom. So that might be one factor.
And after a concussion, is there compelling evidence that really you just need to take it easy and rest? Or again, does that just depend on the person?
So I think we have to be careful with rest because we've had a bit of a pendulum swing over the last decade or so of concussion management. So I think most folks, clinicians in the field and researchers agree that you shouldn't immediately go back into the fray and expose yourself to repetitive impacts that because you're in a particularly vulnerable state, we think, or the brain is. But moving to the other end of the spectrum and saying absolutely no rest, no thinking, no, there's not a lot of evidence that alters the rate of improvement. And if anything, sort of complete focus on symptoms, and it's called cocooning, where you go into a dark room and you have absolutely no stimulus, is thought to actually prolong recovery. So a little bit of common sense, I think, goes a long way.
We've got about 15 seconds left.
So on that topic, I think it's really important for families to understand that while you should not put yourself at risk for more concussions, that cocoon therapy is also not a good idea because it makes especially young athletes very vulnerable to mental health issues. If life revolves around the social and social aspect of the sport, taking away from school, taking away from sports entirely can actually make things worse. So you certainly don't want to put them back in the field, but usually what we tell our student athletes is let your symptoms be the guide.
How interesting. Nick, Tom, Kay, thank you so much for being with us. And thank you for being with our first IU Matters show featuring conversations about important research underway here at IU. So again, we want to thank our roundtable panel of experts. We wish you well in your continued efforts to keep our athletes and all of us safer. Thanks to our staff behind the scenes as well. I'm Ann Ryder. We will see you next time on IU Matters.
IU Matters Concussion Research is a co-production of Indiana University Office of the Vice Provost for Research, Indiana University Media School, and WTIU.